I'm absolutely amazed that my channel's actually managed to hit 25,000 subscribers. Thank you to anyone that's actually watched, subscribed, liked, or even commented on any of my videos. Without your support, I wouldn't have been able to even get here. Let's just make a coffee and I'll ask some of the burning questions that you have in this AMA. So just going up to the studio where I normally shoot all my videos, where we'll also be doing this AMA. So if you're wondering about what I need to do to actually set up, let's go and have a look. Well, just as I'm setting up, so we've actually got two options for audio. So I'm actually recording through my lavalier mic at the moment. We also have a mic up here. Now I'd just like to make a big thank you to everyone that's asked a question. We'll be going through them shortly. And there's so many to get through, so I've tried to break them down into different concepts. However, any ones that I can't get to or I haven't covered in here, I will make a personal comment on there. And just thank you to anyone that's actually contributed, commented, actually liked any of my videos. The first one we're going to go through, and this is from one of my patrons, Abe King. He asks, what are the major differences in the designing between building engineers and bridge engineers? And how did you succeed in both? Well, to succeed in both, it's really about the same thing. It's about increasing your communication skills. I've said this many a time. You need to be good at both the engineering, but the thing that's going to make you accelerate your career further is your communication skills. Because anytime you need to deal with external parties, they're going to be valued about how you communicate, not the actual engineering that you develop. Yes, the engineering is important. You want to make sure that it actually stands up and is efficient. However, they're skills that are quite easy to build over time. Your communication skills are something you need to work on even more. So what is the main difference between bridges and buildings? Well, other than the fact that one covers over a main area, has longer spans, obviously with the bridges, where buildings is probably a little bit more complex. But there's different complexities here. So buildings may have different load paths, transfer structures, and how you're dealing with earthquake loads and other elements that make the complexity in building design quite interesting to deal with. Where in bridges, you're really dealing with single spans. You got a little bit more simple support, but you also need to also look at the temporary conditions. So how are you going to put it in place? It's got these really large spans. So the bridges need to be built in stages, and the construction stage services is really the major difference, because a building is quite easy. You just prop it up, you build it, and you get into its final state, where the bridge may have major design forces that you need to deal with during the construction of it. The other major difference between the bridges is the fact is when they're outside, they're more thoroughly exposed to the environment. So they will expand and contract a lot more. So typically you want to stay with that simply supported structure to allow for those movements so you don't get any locked in stresses from those thermal contraction or expansions. Where in a building, you don't have that complexity. So you need to deal with continuous structures and how that affects different spans and deflections. Where the load path is going through the structure. I would just like to give a quick thanks to obviously Abe, who's made this comment here, but any of my other Patreons. I've got a link in the below description, which will take you to an external website where you can give a small donation to me that helps make this content so much easier through giving me more time to make the content. However, if you're unable to contribute that way, just either liking, commenting, subscribing on any of my videos is all that I ask for. That is probably the easiest way to contribute. Now, the next set I've actually broken down into asking for pay raises and career paths. Big thank you to Deepak Kushner, who really loved the content that I'm putting out. He's actually been a supporter for quite a long time. I've seen many comments back and forth between him. He actually liked and commented on many videos. Thank you for your continued support. It's greatly appreciated. And his question is all about, how do you ask for a raise as a graduate engineer after completing a year at work in your company? Oh, this is about knowing what you're worth and going out there and actually trying to do research in the different fields. It's not about applying for different jobs, but looking through different sectors, actually working out how you've improved over the time. So how have your skills actually improved? What skills and aspects have you put up? So it's about tracking those progressions, about where you've improved, and how you've helped projects go through there. It's about asking them for that pay rise. So being brave and actually asking, look, I believe I've improved. I think I should be increasing my pay based on that, based on the value that I'm bringing to the company. And sometimes based on the company, they may not have the ability to give you more pay at this time, or they don't see the work that you've actually improved. But that's not to be a negative really. What you should be doing in that situation is asking, well, what can I do to get to the next pay rise? Do I need to be able to design certain things by myself? Do I need to do load rundowns, be a certain efficiency? maybe going towards, in Australia, you got your charter status, and they do have other things around the world, completing certain portions of your charter status to help with that progression into the next level. So it's about being brave, going out there and asking for it, knowing what you're worth and how you've actually added additional value to the company. Bring up certain examples, as I may not have seen everything you've done. So the next set of questions is about where I see civil engineering going. So for example, civil utility engineers or different types of engineering fields, and where do I see it going at the moment, especially in Australia? Well, when we're looking at Australia, we can see the rise of materials have gone up. So whether it be concrete, steel, timber, everything is going up through the roof at the moment. So it's making it really hard to build those domestic or commercial builds. However, government's throwing a lot of money into the sector through building additional roads, infrastructure, bridges, railways, and many other aspects like that. So at the moment, the sector is really booming in that transport space. So for the next couple of years, I would recommend that you look at that transport space and starting to grow your career in that situation. Or even just things that are getting built up around it. For example, stations have overbuilds and other things if you're more interested in the building side. It's really exciting. It should be quite busy. It might be a little bit different than my previous years, which is all about the commercial, residential, retail, hotels. But we're moving forward. It's probably going to be more towards that infrastructure, transportation, defense spend, and other areas like that, which should be bringing a whole new skill set and making you into a better, more rounded engineer. Especially if you're starting out, that's probably where you need to be focusing on, but looking for that end goal and where you want your career to be going. The next lot of questions about where I see the future of engineering going. So I've got a special shout out to Brooks, who's obviously been a big commenter in the past as well on my videos. Thank you for all your support and continued support. As for 3D structures, printed spaces, more and more programs are becoming more and more advanced. So we'll be moving out the engineer out of the space, doing more of probably the more complex things that the building can't do. So more of those repetitive tasks will be offloaded from the engineer and moved onto the software. There will be an engineer involved at some aspect to make sure the designs are actually correct. However, our progression is engineering will move a little bit more, less and less on those repetitive tasks and more on the exciting tasks of designing those transfer structures or other things that the program can't really deal with at this stage. But even moving out of that, potentially what will happen is I see that the construction will become more and more automated. So trying to get the people off-site at the moment, especially in Australia, the most expensive part is the construction and the people that need to be involved with the construction of those buildings. So if we can more and more automate the actual construction physically on site, taking the workers out, this is the easiest way to try and reduce prices. So I see in the medium term, potentially that construction demand will go down and down and down as we automate that processes through the robots, construction, or other areas to try and limit the amount of work that you need to do on site. But I do agree, especially with Alvin here, is about how I see that the human input become less and less. Now, this is not necessarily a bad thing in the medium term, as it will allow you to focus on more areas that are more exciting about how to do those connections, how to do those specific structures, and removing some of those repetitive tasks need to be laborious and need to be done. But the good thing as well about removing those repetitive tasks that are going over and over again, you potentially remove some of the human-made error that occurs there. One of the most major errors that occur is through people misinterpreting what the program's saying, inputting incorrectly, or putting on the drawings incorrectly. Second aspect is what type of technical skills that people are actually looking for. Firstly, they want to see that you do have the technical chops. They want to make sure that you actually are a good engineer. You know your stuff. You know the basics. So when I'm trying to ask people about what they're doing with engineering, it's really about those basic subsets. It's not so much people are looking at, I can use this program, or that program. Yes, it is important as we don't want to train you up in those areas, especially you're going later and later in your career. But you need to have a solid understanding in the structural mechanics, those basic load paths, how to design for earthquake, how the building moves. For example, where load paths go, designing transfer slabs, designing transfer beams, designing just general slabs, columns, and other things like that, and just general structural mechanics. So you need to just have a good founding in those aspects. That will get you a long way, and it'll actually get you a lot easier to debug those software programs. Depending on where you are and what company you're applying for, it will vary between company to company. So focusing on the programs is not so important, than more so focusing on those technical skills. So this one's all about what to focus on in your final years of university, and I would recommend you focusing on more of specific to things to do with structures and structural behavior and structural mechanics. So for example, either the vibration or natural modes of a building under sway underneath earthquake, either the vibrations of floor and how that affects your design. These are skills that can be quite hard to pick up, especially later on after you've graduated, but are really useful in your career, as there is specific aspects if you're designing hospitals, trains, or even cinemas, that vibrations through floors can be quite complex and how you can actually deal with them. that will make it more valuable as a subset skill. But really, in your final years, it's about focusing on something you really find interesting, as that final year of university can be quite hard, especially if you're doing your thesis. And if it's something you don't like, it'll make it so much harder. And there's hardly anything you use in final year university that you would need in your career. I really only use the stuff in the first 2 years to actually build your solid founding of structural mechanics is what you use most, even more so than what you use in your final semesters of university. And there's other questions around what you should be doing when you're graduating. So what should I be first focusing on? And that's really where, yes, your communication skills are important, but there's still a lot you need to learn in the engineering side. So when you first start, it's about building your engineering chops and learning how to design. You see, after you just graduated university, all you've really focused on is doing that a little bit of analysis of the software. So getting to what stresses in the beam, working at what reinforcement it may need inside that structure. That's a very big difference to design. You see, design also needs to consider how it's put together, how they're actually going to get things to site. How is it going to be fabricated, erected? Other considerations like, do we need to have a little bit of fat here as a builder may get things wrong? And just good aspects like that. There's a lot of time you don't want to have a lot of repetition to make things really efficient. You want to try and keep things simple and repetitious, and how you make those design considerations. There was also a question about moving into project management and whether you can move it just after graduating. In some aspects, depending on what you're doing, you may be able to move straight into project management. However, I would recommend you slowing down a little bit and getting your chops as an engineer, as a graduate to start off with. As there's still quite a lot to learn, there's a lot of stuff you can pick up in by being a graduate engineer and picking up those design skills, and also make you into a better project manager. There's a lot of time they don't actually know what considerations they need to have in the design, where if you know that, you can actually pull people up saying, no, this is the way to be doing it. It's an easier way to do it here. You can also allow for the time that you need. Someone's always asking that salary question. Now, I've actually got a video on this. So if you want to look down in the below description, I actually cover all aspects of from the UK, the US, and Australia. I'll actually probably link it in the end of this video as well. But it gives you a broad range of the different salaries you expect as you're moving up through your career for all those different sectors. But of course, there's always a variation depending on what field you're in, and this is more focusing on your structural engineering side of it. However, if you're in transport engineering, it may be a little bit higher. If you're in building engineering, just because of how tough the sector is, typically it's a little bit lower, but it does cover all those aspects. The next question is about starting late in your career, and this is from someone who's actually spent a lot of time in the military, so they've learned a lot of life skills in there. And this is thank you to Donald Robinson, who's actually spent a lot of time in management side, personnel skills, and a variety of different aspects. Being actually later in your life will maybe be a little bit harder, as people are expecting you to get paid a little bit more, but you don't have that design skills yet. Apart from taking a little bit of a pay hit to start off with, you should be able to progress quite quickly, as you've got that more of that life skills that people are looking for. And people typically are not too concerned about being later in your career. You may need to push a little to get that first role, but actually after you've got that foot in the door, it'll make it so much easier to progress further and faster. I've actually seen some others progress quite late into their career into the engineering sector, and they're typically progressing better and doing a better job than some of the younger ones who haven't got so much of that life experience. So I don't see it as a downside, but as a benefit there. But what I would recommend is potentially looking for a recruiter to help you out to get that first position. After you got the foot in the door, that's where it's going to be easy sailing, as you will get good recommendations from any of the people that you work with. Obviously, you've built that dedication and hard work through the military, building those interpersonal skills, looking after people, management of people, and that project management skills that are very valuable, especially moving in. So you have some skills that some graduates cannot top. So it might actually make you even more valuable there. I hope you get into the career quite easily, because I think you've deserved it through the amount of effort and dedication that you've obviously put into the Army over the last 10 years. And I hope my videos can keep help inspiring you to be a great engineer. The next lot of questions about moving your career. So for example, if you're either working in India or the Philippines or other countries, and moving it either to Australia or the US or the UK. Well, first up, there's a number of different ways you can actually prove your chops even before you've got to the country. That's either getting a chartered status in iStruct-D, getting a PE in the US, or getting a chartered status through Engineers Australia. And if you need to move there, you may actually need to get your degree validated. The next bit is trying to find that job, and there's a number of different ways you can go about this, as potentially you will need to get engineering skills based on the country that you want to move to. A lot of time, a lot of these countries do outsource some of their engineering to either the Philippines or India. And through that, you can actually get some experience in the local market. So if you can first start off with trying to get that local experience through there, you may actually even be able to move within that same company to move from the Philippines or India and move to the local area, especially if you're good at your job. The problem is, especially if you're moving later in your career, you may need to go back a couple of steps when you move here, as people might not trust that you have the engineering chops, especially in the local market. However, if you do have that, you can take that little bit of a pay hit to start off with. I've got a quick shout out to James, who's actually asked a question. He's actually started in the sector recently as a structural drafter and how he can actually corner the market to be better for his career. Now, you do need to focus on the skills of the drafting and the resourcing. So how can you use Revit, AutoCAD, or whatever other program that you're focusing on? However, I would also recommend that you focus on the design side as well. So how structures are put together, how you detail them, why an engineer has done a certain thing. So if you don't know why he's done a certain thing, it may be worth asking a question if he's not too busy about how he's put together. So understanding those aspects will make you better at your job, as in the future, you'll potentially be able to look up things or design things without having much input from the engineer. Yes, sometimes you'll get it wrong, you will miss certain things, but it makes it so much easier for them. And you will potentially be able to also pick up errors, as no engineer is an island. You do need to design a building as a whole. It's quite easy for someone to pick up a drawing, especially if you're looking in, day out. You may be able to pick up little things they may have missed. So I would recommend you getting into the details and understanding why things are done a certain way, as it will make your life easier, or make the engineer's life easier, and make the building so much better. So next, a lot of questions here about just after graduating university and how can you actually progress your career and what things you should be focusing on. I've answered a little bit at the start, but let's keep going a little bit more. Now they're asking about what type of books would I recommend. So in Australia, there's a couple of books that I would recommend you picking up. You need a good concrete book, and I would recommend the one by Warner. There's a couple of these out there. We're looking for the one by Warner, Rangan, Hall and Fawkes. Is obviously the best option. This is something that I pick up in, day out. There may be an updated version of this, as this is based on the 2009 code, but it's still very useful if you can only pick up this one. Of course, also the other aspect of the major design material that you potentially have is a still design book. So I would recommend you picking up something similar to this. There's also a compendium of the type of steel connections that you can look at. Both of these are very great books if you're looking for design books inside Australia. I would recommend you picking up these. And I'm sure there's equivalents around the world in different areas. If anyone's got any other recommendations for either the UK or the US, please comment below on any books that you would recommend them picking up. As for the courses I would recommend signing up to things like, if you're in Australia, iStruct-D. The other one people have asked about is like, what type of courses would I recommend? There's quite a lot of courses out there. Typically in Australia, iStruct-D offers quite a good range of courses, and even the Concrete Institute, you can pick up a lot of different courses there. One thing I would recommend, especially as a grad, is trying to focus on getting your iStruct-D even in Australia. So iStruct-D really gives you that broad range of concept of how you should be putting a building together and giving you a solid understanding of structural engineering. And they even have some free seminars in here in Australia, within Melbourne, Sydney or Brisbane, that really present a lot of technical aspects. So Omar was actually asked the question about what's the difference between a construction engineer and a design engineer, like negative, positives, hours, and other things like that. Well, a construction engineer, you're typically on site, so you're working builder's hours. So that's normally 6 to 3, so typically you're starting earlier. Typically you will potentially need to also work on weekends, as they work on weekends. You do get some RDOs and other additional aspects to deal with there, but you're more focusing on how buildings getting put together. You're potentially asking questions of the design engineer about how things should be done, and not so much focusing on the design, but the delivery of a project and making sure that they're putting it together effectively. Now, the design engineer will potentially also be going out and doing additional site visits as well there to inspect the work. However, your aspect is just about focusing that buildings is going along the right path. Now, being a construction engineer, there's quite a lot of good things that you can pick up on, but I would recommend you maybe moving it a little bit later in your career so you get some of those design aspects, as there's a lot of stuff that you can potentially miss that will help you out as a construction engineer. So making sure you know how to design slabs, columns, walls, beams, how to put together a building while you're doing certain things. Because if you move into the construction engineering, then you will have a better subset of having a discussion with the engineer about how he's put something together, why he's put together something a certain way, and how you could potentially frame it up differently. Where if you didn't have that experience, you may not know what questions to ask or how to actually improve the design. Now, design engineers, for the hours, it's a little bit easier. It is Monday to Friday. It is typically 9 to 5 with a little bit of overtime. And your overtime will potentially get bigger or smaller depending on the aspects of the work that you're dealing with. So sometimes you may actually need to work more in the week as a design engineer, as potentially have deliverables that you need to deal with. Whereas a construction engineer, your job finishes roughly about the same time as the other engineers do, apart from some paperwork. Obviously now that we're moving into more how I can be productive, what I do in my outside life, a little bit of personal stuff here as well. I'd like to give just a quick shout out to one of them. Obviously I've inspired a lot of people through your comments, and I'll thank you so much. First up, I'll give a quick shout out to Ika, who's actually said I've actually inspired him, has made his job, rekindled his love for structural engineering from what he's something he hated to something he loves. That makes me so much grateful, and this is really why I do it. Thank you so much for actually letting me know, and this will help me keep going and hopefully make better content, and hopefully I can keep inspiring you into the future. And again, I'd just like to give a quick shout out to also one of my other really loyal patrons, Tomio Cantino. But he's asking me, his question is more about personal, about what I really enjoy outside of engineering. So what type of books, what type of movies, TV shows, for example. I'm really fascinated about trying to improve myself. So I'm listening to like Daring Greatly, which is actually more of a technical aspect book about how to be a better leader. Things like I was saying, Never Split the Difference, Soft is the New Hard. And if we're talking about other aspects, I really like movies like from Star Trek, for example, or another one that I really liked was watching The Expanse, a great TV shows. Recently, I've been watching Picard, which is a TV show on Star Trek, which I've liked a lot. Something that I really like as a movie was obviously Serenity. Unfortunately, there was only one episode of Firefly, which I really regret. That was a great series. What type of software do I like to use, especially to be more productive? It really depends. So if I'm doing that one-off calculations, like how to design specific things, I'll focus more on that MathCAD, which is just a one-off. Where if I need to process data, for example, like I'm getting data out of eTabs, I need to post-process it into a solution. This is where I look at either Excel or Python, as it really allows for that repetitious nature. Now, I don't like using Excel so much for those single-off calculations. Why is that? As you can hide problems with inside cells. As you can put anything inside that cell, even though it says it's this answer, you may have actually had an error in there. It's really hard to detect. If using something like MathCAD, you'll be able to look at it and see where the error is, and you're able to see and follow it through line for line. So it depends on which aspects. If I'm just doing a one-off calculation, I'll use MathCAD. If I'm doing more of a data processing, I will look at that Excel or Python scripting. Where do I take the analysis of software? For example, I'm taking analysis out of either eTabs, RAM, or other software, and how do I post-process it? Depending on what I'm designing, so for example, slabs, a lot of the time I will let the program design it there, but more complex things such as transfers of lateral structures, I want to have a little bit more control. So when I want a little bit more control, I will pull it out to an external software. So I've written specific spreadsheets to design buildings. I will pull it out there, so I can have a look at it, drill down on the results, change aspects of it, change different designs, maybe put a little bit more fat in here, a little bit less fat in there, depending on which areas I'm looking at. But typically I will design and post-process it in an external form. This allows me to manipulate the data a little bit easier, actually import it and get it into the design documentations a lot easier. I won't typically rely on the inbuilt design software for something more complex like a lateral design. Ify, the Golden Crust, has actually asked if I could know one thing, especially being in my 30s, late 30s now, that I wish I knew in my 20s. This is not so much about engineering, although the one thing I would say about engineering is keep that learning up, keep learning, and focusing on those communication skills is something that I wished I learned so much earlier. But probably the one thing that I do regret not doing is actually start investing a lot earlier. I've actually missed quite a lot by not investing early enough. So trying to save up my money, either buying the house, investment houses, into the share market or other areas like that. Even when it's crashing, looking at how you can dollar cost average into the market and the gains over time. If you even look at some of the theories about out there and about the pure nature of compounding interest and looking at the numbers, as an engineer, you should be able to look at it and realize how powerful it is to keep investing. So you should want to make sure that you're actually saving and investing that money as early as possible, because the earlier you invest it, the more gain that you'll have in the future and giving you more freedom about where you want to move your career and actually doing your career for something you love and something you actually need to use for that paycheck day to day. Kahuna's actually asked a really funny one here. Well, that is actually fluctuating, changing, and typically going up over time. But a really crazy fact, who knows if it's true though, is the fact that there's actually more people alive today than has ever lived into the past. And if that's true, that's really quite fascinating, realizing how much population there is and how much this world can actually hold. How do I deal with that client communication and how sometimes they can lead to different aspects that we need to change? They want certain answers there. Because sometimes it can be quite baffling. It's really about improving your communication skills. So trying to work out really what their problem is and what they're trying to aim for. Are they looking for a certain aspect in their design? Are they looking for something in there? So what is the actual problem? A lot of the time it is money. But sometimes then you've got to realize saying, if it is money, how can I get them the most cheapest design possible? And what is their design intent? So talking to the architect, what are they actually trying to achieve? Because sometimes you can't actually achieve the most efficient design through what the architects actually approved there. So sometimes you may need to look at it and go, how can we get around this? Yes, they can't have really long spans and have a cheap design, as you will have a really deep, expensive structure. But why do they want that? Is there another way you can frame it up? Is there different areas? Can we make load-bearing walls, for example? And trying to understand the problems that they're having. Sometimes you might actually have really experienced architects who will actually know how they want it framed up, how it's going to go together. They already know the answers before you've even got there. So you've got a quite broad range. So it's actually understanding what is the knowledge of the person that you're dealing with. What are the problems that they're having? And how can you actually deal with them and make it better? So understanding them and communicating effectively for their problems. What I have done in the past is when they're going down a path that I think is really silly and really expensive, I will put together a technical advice notice, not writing so much from a technical side, but why I think a thing should be a certain way, and then them advising me about which way they should go. And by writing it in a written form that I can reference later, when they come back and say, it's really expensive, why did we design it this way? Well, I'll say, well, we offered you different solutions back in the past to try and make this cheaper. You decided to go down the path that we've actually chosen. So that way you can actually go back and actually advise them and guide them and teach them about why they should be doing a certain thing. Now let's move into more of that technical side and the technical aspects of questions about technical designs. Some of those burning questions you've always had. Now there is some aspects that will move into full videos, and especially some of the ones that have requested them, but these are more of those simple questions I quickly answer. The first one is from Robin, who's asked, what is the natural frequency of buildings and how does it affect seismic or wind design? Well, the first easiest one for wind design, it doesn't affect quite a lot unless you've got a really wind sensitive structure, so really a low vibration structure. And you will see that in buildings in oscillating situations. I've just got a video on that about how the lower the dynamics of the buildings can actually make a worse structure. So having a building that's really flexible can be quite bad and actually have higher wind loads than if that structure was as stiff as possible. Where earthquakes, vibrations and softness is really beneficial. So it's about balancing those two. Because when earthquakes is about shaking the stories and the floors, so your building and your seismic behavior is all about those natural frequencies, and you will get dissipated forces as the building shakes backwards and forwards. Also, modal mass participation is a really good way to look at how the building is behaving. Is it behaving as you expected? Is it behaving better or poor? So for example, you want to make sure that your building is not torsionally governed, because natural frequencies form into two things. They're either translation in X, translation in the Y, or torsion. Now, torsion is really the bane of any engineer, even in your stability systems. Torsions will help break the walls as it tries to twist. It will help break those header beams. So when you're looking at structure, you want to make sure you're not torsionally governed, and you want to make sure that your torsion mode is that third natural frequency. So you want to make sure your translation in the weak direction, translation in the strong direction, and torsion wherever possible, and trying to get that arrangement. Another good thing about natural frequency is about how the building is behaving and modeling. You can oversee, is there actually errors in your model? So are other aspects dancing? So is something buckled a little bit too early, or is something not connected? So looking at your natural frequency is a really good way to debug your FE models. Next one is about composite design and about not utilizing the composite nature of beams. There will be some benefit here of not having enough studs in there, but it's really little. You won't get that same compression action. Even if you're looking at those friction forces, they will slide against each other. So that's why you need the shear studs locked in. And if they slide against each other, they're not going to act as one. You will get some benefit as the slab will span a certain distance and the beam will slab a certain distance. And the load share will be roughly against their eyes, but the eye of the beam is so much higher, not only for the depth, but also for the E. So it's EI. And the long-term stiffness of a concrete structure is actually divided by a third. So the ratio is quite a lot less. Although there will be some load share, typically if you haven't got enough studs in there, you'll rely 100% on the beam and not rely on the shear studs in the design. As when slides, the beam will take a majority of the load. You also need to consider that before the concrete stacks are hardened, the beam needs to support 100% of the wet weight as well. So typically even under a load share, when you don't have those shear studs, majority of the load will go to the structural beam. Bert's actually asked about how we impact the load path of something over. So for example, we've got a road and a wheel path on top of a retaining wall, and how that load transfers into the vertical structure and how that pressure affects our design. Now, there's a number of recovery methods as you discussed. Normally those cruder methods, which are the ones by hand in AS 4100, they're more of a crude assessment and just a structural assessment about how the load is going through, and typically will be a little bit conservative. Where if you go into more that Plaxis analysis, is more assessing the load path going through the different stratums and how that's affecting against the pressure. So we'll give you a more accurate result. So using either of them would be quite beneficial, but if you really want to get that more detailed and refined approach, this is really where you need to go for the Plaxis assessment. Moses has asked about the development of reinforcement and how that affects, especially in a strut and tie, because he's talking about a node. The one aspect about strut and tie is not development at the back of the node, it's a development at the start. So if you have a look at an FE assessment, it starts before the node is where the tension forces start, and then it goes into a compression nature. So you've got quite a long way. There's actually ways of estimating this in ACI, where if you're taking the angle, the middle point of the node, and go straight down, that's where you potentially can start the development back from that location. If you don't have enough development, obviously you need to reduce the number of stress the bar can receive. So if you can't develop at 100% by that location, you need to add more reinforcement. It's only a certain percent developed. So if that's 60% developed, you will need a lot more reinforcement than if it's 100 or 80%. So for example, if you can't develop the reinforcement by the time you get to that point, you will need to look at it and say, well, what is the percentage of development? So you times the AST by that development and making sure that you've got enough reinforcement in that location. So you just need to add more reinforcement. The next question is about moment redistribution, especially going through column and slab connections, and why sometimes the higher columns will fail more so than the bottom columns. There's a couple of reasons here. As your load goes down, yes, the load's getting on it, so the column needs to support more load. But that's also benefit you for the moment and how the moment transfers in there. So if I've got a column right down the bottom of a really tall building, I'll typically only crack that to 1 or something, as potentially not overcoming the tension forces from the slab, so the column potentially is uncracked. So the compression force plus the moment doesn't lead to a tension force in the column, which is the bane of any concrete design. That's why the bottom columns, despite being more stressed, are potentially less likely to fail. When if you go up near the top, you don't have as much compression force. So that moment can cause quite a big moment and actually crack the column a lot earlier and cause a local failure. So at the top of the building, you need to be careful about the moments that are being induced into it, while the bottom of the tower, you need to be more careful about the axial force that's actually applied to it. So at the top of the tower as well, the other thing to consider is you are getting the moment in there, you'll need to have that column more cracked than the ones at the bottom. So the ones at the bottom are 1 and the ones at the top might be 0.4. There is guidance in such things as AS3600 where it suggests about how to crack a column. I'm sure there's similar in other codes around the world about what level of compression force and how to look at it. But the easiest way to think about it is look at the moments being induced on the column. Does the P on A exceed the M on Z? So for example, if the moment was applied, does the column actually go into tension? If the column goes into tension, it will be cracked, and applying the critical forces. So making sure you've got either enough moment capacity in that column or enough size to resist those compression actions. And as I said, there was also a number of different video requests, and I will put them down into the list, and thank you for all your support. So this is a little bit of a different one. This is a really big thank you to anyone that's, I've got linked to a number of different videos that you may be interested in. And again, if you're interested in supporting the channel, I've got links to my Patreon in the below description, much like these many members here. Without their support, this type of content would not be possible. And as always, stay safe, keep learning, and I'll see you next week. Bye.